Okay, investigation 3, it's exploring angles of polygons. So we're going to draw a few polygons. It doesn't matter if they are regular, it doesn't matter if they're convex, it doesn't matter if they're concave. But we're going to be dealing with diagonals. Remember, the definition of diagonal is connecting non-adjacent vertices. Connecting non-adjacent vertices is what a diagonal is. So if I take a, let's say, a rectangle or a square, anything with 4 sides, and I want to make the diagonal from any non-adjacent vertice, it just goes across. If I have a pentagon and I want to connect the non-adjacent vertices, I just pick a vertice and I connect every vertice that is not directly next to it, because otherwise I'd just be recreating the side. Okay. What we need to remember here, how many degrees is in a triangle? In a triangle. 180, right? So if this has 2 triangles in it, how many degrees are inside of this square? It has 2 triangles. 360, right? So this one has 360 degrees. If I have 1, 2, 3 triangles, then I have how many degrees? Did y'all guys ever play like skateboarding games or anything like that? Somebody, I'm sure. If you say you did a 180, you did a half circle, right? If you do a 360, you did a full circle. If you did a 540, it's 1.5. 720 is 2 circles. Tony Hawk is famous for like a 900 and some change. Yeah. Okay, so when we have 3, it's 540. But I want to notice something. This has 4 sides. This has 5 sides. What if I drew a hexagon? See if I can draw a hexagon first. As a prediction, how many triangles do you think I'm going to make in a 6-sided figure? 4 sides, I had 2 triangles. 5 sides, I had 3 triangles. So 6 sides, I'll have, Trayton says 4. So let's start. Here's a vertex. I chose this vertex. I'm going to connect all non-adjacent vertices. So there's 1, there's 2, there's 3, and here's 4. So 1, 2, 3, and 4. So 6 sides, I had 4. So what is the relationship between the number of sides and the number of triangles? What happens? I subtract by 2. So 4 minus 2 gives me 2 triangles. 5 minus 2 gives me 3 triangles. 6 minus 2 gives me, oh sorry, oops. If I can do math correctly and write it down at the same time. 6 minus 2 gives me 4 triangles. So if we take the number of sides and subtract 2 from it, we get the number of triangles, right? Created by connecting non-adjacent vertices, by the diagonals. So what's good about this is it develops a formula. If I know each triangle is worth 180 degrees, all I have to do is take 180 and multiply it by the number of triangles, right? So if I know the number of triangles is going to be the number of sides minus 2, all I'm left to do is multiply it by 180 to find out the total number of degrees that will be inside each one of these types of polygons. And it holds true every single time. If I said I have a dodecagon, how many sides is in a dodecagon? I didn't hear that. 12. Good. So in a dodecagon, there's 12 sides. So the number of sides is 12. So I just plug it in. I take 180, and I multiply it by 12 minus 2. So I take the inside of the parentheses first, which is 10. So I take 180, and I multiply it by 10, and I get 1800 degrees. That's the number of interiors for interior angles. Now, if it's a regular polygon, I would just take the number of angles that are made inside of that polygon and find out what each measure would be. Okay, so here's your formula. This would be your formula for finding sum of all interior angles. It's 180 multiplied by n minus 2. That's for finding the sum of all interior angles. So if I had a square, what do we know about the angles of a square? And a square is a regular parallelogram, a regular quadrilateral, right? It has 4 sides. So if I take 360 and I divide it by 4, if you had a calculator, you'd get 90. So what they do, if it's regular, it's really simple. You just take the total number of degrees inside and you divide it by the total number of angles. So if there's 4 sides, there's going to be 4 angles. If there's 5 sides, there's going to be 1, 2, 3, 4, 5 angles. If there's 6 sides, there's going to be 6 angles. So if I know that there are 6 sides in my regular polygon, then I need to find out how many degrees are in the total. So we're going to take 6, subtract it from 2, multiply it by 180. We get 4 multiplied by 180, which is 720. If the question says, what is the measure of the interior angle of a regular hexagon, then I know hexagon is 6. So I found out the total degrees inside. In order to find out what each angle is, I divide by however many angles there are, and there are 6. And I find out that each angle is 120 degrees. So for the angle measure of the angle measure in a regular polygon, you will find that we'll use the same formula, modified very slightly. So it goes n minus 2 still, multiplied by 180 still, but all we're going to do now is divide it by the number of sides, or the number of angles, which is the same. Okay, so here's the 2 formulas that you get out of investigation 3. Any questions about it? So this was all for interior angles. If we're dealing with exterior angles, I need to remind you what an exterior angle is. An exterior angle is something that if I extended this out, this would be my exterior angle, that little piece right there. And then if I extended all of these out, like that, all of these exterior angles here would add up always to 360. The exterior angles of any polygon always add up to 360. No matter what. And it works every single time. So exterior angles always add up to 360. So if I wanted to find what the measure of an exterior angle was, I just take 360 and divide it by the number of sides. So for this example, this was a pentagon, so it has 5 sides. I take 360. This is only if it's regular, okay? And I divide it by 5. So 360 divided by 5 gives us 72 degrees. So all I do is plug in the number of sides. So this 360 divided by n is the formula for finding of a regular polygon. Exterior angles of a regular polygon. Okay, and that's the last bit for investigation